Boeing, how millions of parts become one airplane. Imagine trying to build a flying machine from millions of individual pieces. Every part has to be manufactured, inspected, tracked, transported, and installed in exactly the right place. Now imagine that one missing component can delay an aircraft worth tens or even hundreds of millions of dollars. And somehow, Boeing does this again and again. But how? How do millions of parts, thousands of suppliers, massive factories, and a global logistics network come together to create one aircraft? The answer reveals one of the most complicated industrial businesses on Earth. When you look at a Boeing airplane, you see a finished product. A giant fuselage. Huge wings. Jet engines. Landing gear. Seats. Windows. But Boeing doesn't really start with an airplane. It starts with a supply chain. The famous millions of parts figure is often used to describe the enormous complexity of a modern commercial aircraft. But there's an important distinction. A physical part isn't always the same thing as a part number. Boeing says its global aviation parts business provides access to more than 15 million individual part numbers. That gives you an idea of the scale behind the business. Because Boeing doesn't just need to know what a component looks like. It needs to know where it came from, how it was manufactured, when it arrived, where it belongs, and whether it meets the required specifications. And that turns airplane manufacturing into something much bigger than an engineering challenge. It becomes a supply chain challenge. Before a single piece is installed, engineers have already designed an enormous digital blueprint. Every major system has to work with every other system. The wings have to withstand enormous forces. The fuselage has to survive repeated pressurization. The landing gear has to absorb the impact of landing. Electrical systems have to distribute power. Hydraulic systems have to control critical functions. Flight control systems have to respond precisely. And all of these systems have to fit together. Think of it as a three-dimensional puzzle. Except this puzzle will eventually fly hundreds of miles per hour, thousands of feet above the ground. There is no room for guesswork. Once production begins, materials and components start moving through the global supply chain. Metals. Composite materials. Fasteners. Wiring. Avionics. Hydraulic components. Landing gear. Cabin systems. And thousands of other components. But here's what makes aerospace manufacturing different. Boeing doesn't just need the physical part. It needs the information behind the part. Where was it manufactured? Was it inspected? Does the documentation match? Was it modified? Is it approved for installation? This creates something incredibly important. Traceability. If a problem is discovered later, manufacturers need to know which aircraft and which components could potentially be affected. So every component becomes part of a much larger information system. Then the pieces begin arriving at final assembly. And this is where the airplane starts becoming recognizable. Large structural sections are positioned. Fuselage sections are joined. Wings are integrated. Electrical wiring is installed. Hydraulic systems are connected. Cabin interiors are added. Landing gear is attached. And eventually, the engines are integrated. But there's one critical word. Sequence. You can't simply install everything whenever you want. Some components have to be installed before others. Some systems become difficult to access once another section is closed. Some inspections must happen before production can continue. It's similar to building a skyscraper where thousands of pipes and cables are hidden inside the walls. If you install something in the wrong order, fixing it later can become extremely expensive. And this is where manufacturing efficiency becomes financial performance. Every additional hour costs money. Every delay can affect deliveries. And every disruption can spread through the supply chain. That's why the airplane factory is also a logistics machine. Boeing needs components to arrive at the correct location, at the correct time, in the correct condition. And the business doesn't stop when the aircraft leaves the factory. In fact, that's when another part of the business begins. The aftermarket. Airlines need replacement parts. Aircraft need maintenance. Components eventually need repairs or replacement. And Boeing operates a massive parts and services ecosystem around aircraft already in operation. Its global parts network provides access to more than 15 million individual part numbers. That creates an important business advantage. Selling an aircraft is one transaction. Supporting that aircraft for years can create many more. This is one reason aerospace is such a powerful business. The aircraft has a long economic life. And the companies supporting it can continue generating revenue long after the original sale. Now consider something even more surprising. Imagine an aircraft that is almost completely finished. The engines are installed. The interior is complete. The paint is finished. The aircraft looks ready to leave the factory. But one critical component is missing. Suddenly, a relatively inexpensive part can become a very expensive problem. Because the cost isn't just the price of the part. There can be additional labor, storage, transportation, schedule disruption, customer delays, and potentially wider production consequences. This is why supply chain management is not just an operational issue. For a company like Boeing, it can directly affect financial performance. And this brings us to the technology most people don't see. When people think about Boeing technology, they think about jet engines, advanced materials, avionics, and flight computers. But one of the most important technologies is something much less visible. Coordination. Boeing has to coordinate engineers, factories, suppliers, logistics companies, quality teams, airlines, maintenance organizations, and regulators. Thousands of processes have to move together. Boeing also uses digital tools to improve parts forecasting and supply chain visibility. Its parts planning hub allows customers to share forecasts and inventory information, helping Boeing make better decisions about parts availability and supplier management. So the modern airplane factory isn't just a place filled with machines. It's a massive information network. And that's where the bigger business lesson appears. Boeing isn't simply selling airplanes. It's operating an ecosystem. The aircraft itself is only the beginning. Around it are parts, maintenance, repairs, upgrades, training, logistics, technical support, and long-term services. This creates an economic system that can continue for decades. And that's also why commercial aircraft manufacturing is so difficult to compete in. You don't just need a good airplane. You need engineering expertise, factories, qualified suppliers, global logistics, regulatory approval, quality systems, maintenance infrastructure, customer relationships, and decades of accumulated knowledge. All of these systems have to work together. That's why Boeing and Airbus dominate commercial aviation. The real competitive advantage isn't simply the aircraft. It's the ecosystem behind the aircraft. So the next time you sit inside a Boeing airplane, look around. The seat you're sitting in. The wiring behind the walls. The fasteners holding structures together. The hydraulic systems. The landing gear. The engines. The electronics. The cabin equipment. And thousands of components you will never see. Every one of them had to arrive at the right place. At the right time. Built to the required specification. And verified before becoming part of a flying machine. That's the real Boeing story. The airplane isn't just the product. The real product is Boeing's ability to coordinate one of the most complicated manufacturing and supply chain systems on Earth. Millions of components go in. One airplane comes out. And behind that airplane is a global industrial machine worth billions. Because in aerospace, the greatest engineering achievement isn't simply building something that can fly. It's making millions of individual pieces behave like one machine.